Hello, class. I am. I'm not even sure if this is going to record or if this is going to use all of my hotspot um, stuff, but I'm going to try and start this. This is a lecture that I'll just give you the background. We lost power here in Hull for about 36 hours, and then when it came back online. I thought, well, that's great, because I was freezing last night. Actually, I wasn't. I've got a heater that, anyway. Um, so I can't really use Zoom to record these things, I felt. And so I'm experimenting right now to see if there is a way that I can record it on my camera with Zoom because the internet did not come back. I've got a guy coming out tomorrow to work on the internet, but I can't really do anything with it with my hotspot. I only have 10 gigabytes and stuff like that. So we're going to see. This is a lecture that I've been wanting to do for a while. And I want to see if I can at least record it today, even though I won't be able to upload it until tomorrow evening, maybe. But we'll see how it goes. And I hope I don't use all my hotspot doing this. So this is the most important equation lecture that I'm going to give you. And I always like to start off with a comparison, right? 0, 10, all the way up to age 80. And I've got 3 different columns here. And these 3 different columns, the first is how much money you have on you. The second is how much money you could get your hands on pretty quickly. And the third is what your net value or your net assets are. And when you're 0 years old, I like to say, well, you start with a penny, right? You've got a penny on you, or you could probably get your hands on a penny, right? And then if you went home, laying around the house, you probably have about a dime. And if you were looking at your net worth at that time, well, it's about $1. So you're starting off pretty low. People are taking care of you. But when you're 10, well, I figure that in your pocket, you've got about 10 cents, or you could go home, you could find that someplace laying around pretty quickly. If you had to go home and scrape up as much money as you could find, you could probably get $1, right? And then what's your net worth at the time? Well, you got some money that your uncle gave you that you stuck in the bank or whatever, and then the money that you still owe me. It comes to about a net asset value of $10. And then when you're 20, well, you got about $1 in your wallet, right? You could easily get $1. And then you go home, you got probably $10, laying around the house someplace. So that's not too much of a problem. And, if you had to, your net value about 20 is, well, it's probably negative due to the student loans that you've been getting the whole time. But let's say it's around $100. When you're 30, well, you got about $10 in your wallet. And you could go home, you probably got $100 laying around the house that you could get your hands on pretty quickly. And your net value is probably about, your net assets is probably around 1,000 because even though you may have bought a house at that time, the money that you're paying on the 2 cars and all of that stuff has really, taken you down. So you only got about 1,000 net worth at 30. At 40, you've got $100 in your pocket. And you could go home and around the house, you've got about $1,000 of personal property, right? Maybe a little more than that. I don't know. Maybe a little less. Maybe your net assets at that time are about $10,000, right? Because the kids are a little more grown up and you've been saving, you and your wife or you and your husband have been saving for that 10 years since you've had the kids, and you've got about $10,000, and you're going to need that anyway. Now, when you're 50, you got about $1,000 in your wallet, or, you can go and grab that cash someplace, probably hanging around the house or something like that. Or you could take it out of the bank. You've got about $10,000 in personal property because you've paid off one of the cars and, you've got the other car, you've only got a little bit on. We paid off most of the house by this time, or not most of it, but at least some of it. So you probably got about $100,000 in equity in your retirement accounts and all of that. And a lot of you are saying, hey, you know, this should probably be when I'm 40. Yes, and for most people it was when they were 40, but I like to push it out here to not make people look bad. When you're 60, you should have $10,000 in your wallet, or be able to get $10,000 almost immediately in cash. Your personal properties, including your cars and some other things, should be about $100,000. You got that new boat, and you've got the cars and all that. And then your net assets should be about $1 million, right? You paid your house off. That house has gone up in value. It's $800,000 now. And with all the other things that you've got, it's about $1 million. You don't have any debt, right? When you're 70, you should be able to get your hands on $100,000 almost immediately. And you should have $1 million in personal property that you've got around the house, right? And then you should have about $10 million in, you know, just assets, net assets. I mean, you're including your $8 million house next to Tom Brady, right? Now, when you're 80, you should have about $1 million in your wallet, or you could easily get your hands on $1 million in cash pretty quickly. And you got about $10 million of personal property, you know, a couple Renoirs, that one, you know, Rembrandt, and then a couple Picassos, not to mention the Learjet that you've had now for a while, and altogether that should come up to about $100 million, right? Now you're saying, well, you know, Professor Grenquist, I'm with you up until about 40, but after 40, I'm not sure if I'm going to have that, you know, 10 million in personal property. And that's right. Now, what I'm really saying here is, what does this mean? What are each one of these steps? You can see that each one of these steps is going up tenfold, isn't it? So I've got a tenfold increase in 10 years. Tenfold increase in 10 years. You know, how would that work? Well, first of all, you're probably thinking to yourself, well, tenfold, right? We've got a rule of 72. And the rule of 72 says, if you divide the interest rate, let's say that you're making 7.2% interest on $10,000 that you put in. So $10,000 at 7.2% interest. How long is it going to take to double that money? 10 years. So it's going to take 10 years to double that money, right? You can see the rule of 72 at play here. I take 72, I divide it by 7.2, and I get 10 years. So if I put my $10,000 in at 7.2%, 10 years later, I'm going to have $20,000. See, it doubled. So that's 2 times, isn't it? Now, when I talk about tenfold, what is that? Tenfold is really 2 to the 3.32, isn't it? It's 2 to the 3.32. So we're not doubling the thing. We're really taking it 3.32 times, aren't we? So let's do that. Let's take 72 and multiply it by 3.32. Now, 72 times 3.32 times 72 equals 239.04, but I'm going to say it's just 239 approximately. So 239. And why did I do that? Because I didn't just double this, right? I doubled, then I doubled, then I doubled. And then I threw in a dash more too. I doubled it 3.32 times, didn't I, in those 10 years? Now, take that 239, you can see why I multiplied the 72 by, because that's to double it. And by multiplying it 232 times, but now we've got 10 years there. So what is my interest rate? So it'd be 239 divided by 10, and that would give me 23.9%. 23.9%. If you can put your money in a bank that gives you 23.9% every day, I mean, you know, all the time, then you could put that penny in there and you would have $1 million 80 years later. You could put $1 in an account at 23.9% and you would have $100 million later. You're probably starting to see now why credit cards are a bad idea, right? Or at least the interest rate on a credit card is a horrible, horrible, horrible idea. That's not the greatest equation, the most important equation I've ever, I've done though. And that's what I wanted to talk to you about today. It's this equation. I'm going to write the equation down so that you can see it. It would be, and I'm going to just put payment here. I'm not going to put monthly payment because there are things that you pay on weekly, right? Let's say that you bought a refrigerator or whatever. Maybe you have to pay by week, but I'm going to show you how this works. And here is the equation. The reason I'm giving you this equation because almost everybody, in fact, I would say literally everybody in their lifetime is going to have to borrow some money for a large major purchase. For most people, that starts with a car. Never started with a car for me. I've never bought a car and had a car loan. That's one of the things that you should never do. You should never buy a car with a car loan. You're an engineer. You can fix any car that's out there. You should learn how to fix any car that's out there. And you should love to work on cars to fix cars. I've had over 130 cars, and I've loved all those cars, and I've loved working on all those cars and everything else. But I've never had a car loan, and that's allowed me to save up my loaning power for houses and buildings and commercial property and apartment complexes and stuff like that. So let me give you the equation. This is the amortization equation, by the way. Amortization equation. And you're probably thinking, I can find this on the internet, but you can't. You can now. I actually found this one. 1 plus I to the n minus 1 divided by I times 1 plus I to the n. And so let's put a bracket around that. And I think that everybody can see that, you know, if we know what the house, let's say we're buying a house for $200,000. If we know what the house value is, and we know what the number, I'm going to just write these down. N is the number of payments. That's payments. And I is the interest rate per payment. Interest rate per payment. And I'm going to give you an example of this. Let's say that the interest was 6% annual. Well, that would be 0.06, right? That's 6%. And then you want to divide it by 12 months because we have 12 monthly payments over the course of the year, and those add up to. Now, if we were looking at, let's say, N, the number of payments, well, for a 30-year loan, that's 360 payments, isn't it? So how would I write this? Let's say that we're looking at what would be the monthly payment for a home that is $200,000, right? So I've got $200,000. That's my principal value. And then I would divide that by 1 plus. Now, when we look at 0.06 divided by 12, that really is going to be 0.005, isn't it? Does everyone see that? 6 divided by 12, 0.06 divided by 12 is going to be 0.005. So 1 plus 0.005 to 360 minus 1 divided by 0.005 times 1 plus 0.005 to the 360, right? And if you do that, I think you're supposed to get $11.99, right? $1,199. I haven't actually checked that, but I just want to make sure that I did it right on this thing. So 1.005 y to the x 360, and does that come out to 4.247? Or wait, no. Oh, that's all wrong. What am I doing? 1.005 y to the x 360 6.022. That's right. Okay, so you've really got 200,000. This is I'll write it out. $200,000 divided by 6.023. I'll round it up, minus 1 divided by 0.005 times 6.023, right? And what that gives you is 1,199. Now, I want to also point out something about the amortization, about compound interest in general, right? Compound interest in general, if we look at it, let's say that this is the interest rate down here, and I'll start at 0, and I'll go up to 15%. And then this is how our payments, right? This is our what our payments, how our payments would change via interest rate across there. Now, when you're working with something that's very inexpensive, like a refrigerator or something like that, and you're going to take credit out on that, you know, the price is much more important to negotiate on that. What you want to do is you want to go into Home Depot and you want to go to the refrigerator section, and then you want to see that, hey, that $2,400 refrigerator, they've got another one with a little scratch on the side of it over here that's $625. Which one should I buy? And that's right. At very, very low cost things, you should really go out and you should really focus like a laser on the price, and getting the price down as low as you possibly can. These aren't really things that you should be borrowing for, right? So if you look at it, it looks very much like this. There isn't much difference whatever you would pay on that thing. It's really the price that you want to negotiate. Now let's say you go out and you get a car. Well, a car, if I look at it over this thing, looks like this, right? So I'm paying more for the car, but then this thing is going up and these payments are going up, and it's really, you know, starting to do it. Now, what about a house? So this is a car, this is a fridge. What about a house? A house is like this. In fact, it's much steeper even than that, as you can see. I should have even drawn it more, but I can't. With a house, you really are much more concerned with the interest rate than you are with the price, right? You want a 0 interest rate, but the difference between 0 and 3% is really negligible. When you're going up to 15% is when you're really, you know, 0 and 3%, well, where are you? Right about here. But at 15%, you're way up here. So, you know, you've just got to look at it there. Anyway, that is the most important equation. I use that equation all the time, and you can use it for different ways too. I mean, you can use it to find the payment, but couldn't you also say, okay, well, I know how much I can pay per month, and then put this over there with the payment, and that would tell you the maximum principal value of the house that you can afford to buy, right? You could also switch this around and look at the interest compared to the number, but I can tell you right now that we're the only country in the world that gives 30-year fixed rate mortgages. And take advantage of that. That's really like the government saying to you, okay, here you go. You can have a house for nothing. All right, I'm going to hold it there and see if I can get this up on the web. I'm not sure if I can, but we'll see.